Hi everyone and welcome to our GCSE chemistry trial session. Just while we wait for everyone to join, can you let me know if you can hear me and see my screen in the Q&A? We will make a start in approximately 3 to 4 minutes. Hi everyone and welcome to our GCSE chemistry session. Just while we wait for everyone to join, we'll just wait another couple of minutes. Can you let me know in the Q&A if you can hear me and see my screen? Okay, we will make a start now. So welcome everyone to our GCSE chemistry trial session. This is just the trial session a week before our GCSE Summer Course, which will run for 10 weeks, and we'll go over the details at the end of the lesson. Okay, so if we begin today, in today's lesson, we're going to be looking at the greenhouse effect, and this is part of Unit 9, Chemistry of the Atmosphere. Okay, so you will find this in paper 2. So our agenda for today's lesson is that we're going to go over the early atmosphere. We're going to look at how the levels of carbon dioxide decreased and oxygen levels increased. and then we're going to finish off by looking at the stages of the greenhouse effect. Okay, so those are the three things aligned for today. So if we begin, we're going to start off by looking at the early atmosphere. So the key word here is atmosphere. You need to know what the atmosphere actually means. And it's really simple. The atmosphere is a thin layer which surrounds the Earth, and it's a layer of gases. Okay, so if we have the Earth over here, we have an extremely thin layer around the Earth. It's not the best drawing. Extremely thin layer around the Earth which contains gases. And we're going to go over those gases later in today's lesson. So it contains gases, and this is what ultimately keeps the Earth warm. Okay, so that's what atmosphere is. It's a layer of gases which surround the Earth, and it's really thin. Okay, so I would be noting down the definition of atmosphere. The layer of gases which surrounds the Earth. Okay, and remember the atmosphere is thin layer of gases. Okay, now here you need to know what percentage of amounts each gas is contained within. Now the atmosphere has many gases within it. These are the ones you need to know for the Earth. Okay, and these are the ones which are mentioned in the specification. So you need to know that there was a lot of water vapor in the early atmosphere, and there were a few other gases, and there's a few other gases now, but the ones we need to focus on are the carbon dioxide levels, the oxygen levels, and the nitrogen levels. Okay, these are the ones which are mentioned in the specification. Okay, now the key point over here is that in the early atmosphere there was a lot of carbon dioxide, and it's the gas that made up most of the atmosphere in those times. However, nowadays the carbon dioxide levels have dropped, and we only have a small amount of carbon dioxide. Okay, oxygen levels in the early atmosphere, there was very little, because there was very little life in the early atmosphere. And then as life started to develop, we started to get more oxygen. So now we're at 21% oxygen. Now I have to tell you that the specification and exam questions, they allow oxygen to be 20% and nitrogen levels to be 80%. Okay, so if you can't remember the exact figures, you can round them off to 20 and 80%. Okay, the nitrogen levels in the early atmosphere were very little, and in the modern atmosphere we have a lot of nitrogen, and we're going to have a look at the reason for that as well in later in today's lesson. Okay, so I would just note this table down just quickly and make sure you're learning the percentages. We're going to have a look at the reasons for each of these changes next in this lesson. Okay, and you have the PowerPoint as well, so all your resources are there. Okay, so the carbon dioxide levels, we can see decreased. We can see the oxygen levels increased, and trace means not much. Okay, and we can see that the nitrogen levels also increase, and there's a reason behind this, and you need to know the reasons. Okay, so to summarize off this slide, we have the atmosphere, which you need to know the definition of. It's a layer of gases, a thin layer which surrounds the Earth, and these are the percentages you need to know. The gases which are in our atmosphere include carbon dioxide, oxygen, nitrogen, water vapor, and other minimal gases. And In the early atmosphere and the modern atmosphere, we have a little amount of both of them. Okay, so all of these are essentially greenhouse gases. Okay, and these are the ones you need to know for the specification. Okay, having knowledge of the water vapor and other gases will also give you a better understanding of the early atmosphere. Okay, so just familiarize yourself with the percentages. Carbon dioxide levels decreased, oxygen levels increased, nitrogen levels also increased. Okay, so if we move on, now we're looking at what was contained within the Earth's early atmosphere. Okay, so as you can see, in the Earth's early atmosphere, there were a lot of volcanoes, and we all know what volcanoes do. Volcanoes erupt and they eject a lot of ash gases into the atmosphere. And the main gas that they erupt is nitrogen. Okay, so we have a volcano. In the early atmosphere, there were a lot of volcanoes. Okay, and when the volcanoes erupted, they released a lot of gases into the atmosphere. Okay, they released a lot of gases into the atmosphere, and most of them stayed in the atmosphere. The main one was nitrogen. Okay, so most of this was nitrogen, and that's why the nitrogen levels have increased, because most of the early atmosphere was made of volcanoes, and volcanoes erupted. They released a lot of gases into the atmosphere, and one of the main supply of gases that were released was nitrogen, and that's what triggered the nitrogen levels to increase. Okay, water vapor is also a greenhouse gas. Okay, this is also a greenhouse gas, and water vapor also was released from volcanoes. It's one of the gases which are released from volcanoes, and we naturally find water vapor in the air. Now, because the volcanoes have been erupting, water vapor has been released, and now the water vapor levels decreased. So if we look here, we had a lot of water vapor in the atmosphere, and as you can see, the water vapor levels, they decrease. But as you can see, the water vapor levels decrease because they condense to form the oceans. So in the early atmosphere, there wasn't much oceans, and now we have a lot of oceans in the modern atmosphere, because the water vapor, which is a greenhouse gas, it condensed. Remember, you have solid, liquid, and gas. We had water vapor, which is a gas. It condensed to form a liquid, and these are the oceans that we find in the modern atmosphere. Okay, so the water vapor in the atmosphere condensed to form the oceans, and that caused a decrease in water vapor levels. Okay, so the volcanoes erupting triggered an increase in nitrogen levels, and the water vapor condensing caused the oceans to increase and a decrease in the water vapor levels. Okay, now evidence for the early atmosphere is limited, okay, because of the time scale of 4.6 billion years. So humans have only been around for 4.6 billion years. and the Earth has been around for a long time. So what we can understand is that our knowledge is actually limited because we've only been here for such a short span of time. We've not seen what the early atmosphere used to be like. So that's a drawback, a setback, which has limited our understanding of the Earth's early atmosphere. Okay, this is a key point over here. It's a common exam question that you would come across. Okay, so to summarize while you guys take notes of this slide, nitrogen levels increased due to lots of volcanoes. That caused an increase in nitrogen levels. Okay, because volcanoes, when they erupt, they release lots of gases, and the main supply was nitrogen. Water vapor levels decreased because they condensed to form the oceans, and that caused an increase in the oceans. And the evidence for the early atmosphere is limited because of the time scale of 4.6 billion years. Okay, so moving on, how did the CO2 levels decrease? So if we go back to our first slide, we can see that the CO2 levels decreased over here. Okay, so the CO2 levels decreased. In the early atmosphere, we used to have a lot of CO2, and now in the modern atmosphere, we have a really small amount. So why is this? Well, there are a few reasons. The first thing is that the carbon dioxide, which was in the air, dissolved in the oceans. Okay, so remember, we saw a decrease in water vapor levels because the water vapor levels were forming the oceans. Okay, the water vapor levels form the oceans. Now the carbon dioxide, which used to be in a large amount in the early atmosphere, dissolved in the oceans. Okay, because the oceans took a large amount of space. So they took a large amount of space. We can see that the carbon dioxide actually dissolves in the oceans. Okay, that's one reason for why CO2 levels decreased. Now, green algae and plants carried out photosynthesis. So there's three main reasons you need to know. There's the first, there's the second, and here's the third. Okay, so green algae and plants carried out photosynthesis. Now, the equation for photosynthesis is when you take the carbon dioxide and water and you turn it into glucose and oxygen. Okay, so we've got the photosynthesis equation. So we've got our carbon dioxide reacting with the water, and that produces the glucose and the oxygen. Okay, so we have our reactants here, and we have the product here. Okay, and this is the equation you need to learn. Now, the carbon dioxide in the atmosphere, a reason why it declined was because of plants carrying out photosynthesis, because photosynthesis requires carbon dioxide. Yeah, so the Plants take in the carbon dioxide from the atmosphere, react it with the water, and then they produce the products, which are glucose and oxygen. Okay, so if the carbon dioxide are being used up, therefore it led to a decline in the carbon dioxide levels. Okay, now the third reason for a decline in the CO2 levels is that some of the carbon the organisms took in from the atmosphere and oceans becomes locked in rocks and fossil fuels after the organism has died. Okay, so organisms need to survive, and when they survive, organisms, they eat food, so they eat plants or food, and they drink water. Okay, they drink water. Now, after they've eaten the plants and food and drink water, some of this is excreted as feces or urine, but some of it is also stored by the organism itself. Okay, so some of the carbon is just stored in the organism instead of being released back into the atmosphere. Okay, so some of it is stored in the organism. Okay, so some is stored, and because some of it is stored, when the organism dies and it's locked up in rocks and turns into a fossil fuel, the carbon is still trapped inside the organism. Okay, so let's say we had a decomposer. Let's say we had a worm. A worm would drink water, and it would drink and it would eat, let's say, at some plants. Okay, now the carbon from the water will go into the worm, and carbon from the plants would go into the worm as well. Okay, the worm will excrete some of this as urine or feces. However, some is still inside the worm. When the worm dies, the carbon is still inside the worm. And then eventually, when the worm decomposes and becomes locked up in becomes a fossil, so it will eventually become a fossil. All animals eventually become fossils after they're compressed over time. The carbon will be trapped inside the worm forever, and that's also caused a decline in the carbon dioxide levels. Okay, and carbon dioxide can also become locked up in rocks. Okay, so if we summarize this slide, you guys can take notes now. So one of the main reasons why the carbon dioxide levels decreased was because the carbon dioxide dissolved in the oceans. Okay, the second reason is due to photosynthesis, plants carrying out photosynthesis. And here's the photosynthesis equation. We've got the carbon dioxide, water producing glucose and oxygen. And then the final reason is because some of the carbon organisms took in through food, plants, water becomes locked up. That's a key word you need to know. It becomes locked up in the organism until it's died. It'll become a fossil and it can burn, but it essentially becomes locked up. Okay, so as some of it is stored, that's caused a decrease in the CO2 levels. Okay, if you have any questions, just let me know in the Q&A and I'm here to answer them. So moving on. how did the oxygen levels increase? So we've had a look at how the carbon dioxide levels decreased, but how did the oxygen levels increase? You also need to know that. Okay, so the main reason of how the oxygen levels increase is due to photosynthesis. We've seen that green plants and algae carry out photosynthesis. Okay, when they're carrying out photosynthesis, again, we have the reactants here and we have the products here. When they're carrying out photosynthesis, we can see that they're producing glucose and oxygen. And when they're producing oxygen, the oxygen stays in the atmosphere. Okay? It stays in the atmosphere until humans carry out respiration. Okay? Now, because there were very few humans at the time, less respiration would be carried out. And that's now decreasing because more humans are in our planet and more are carrying out respiration. But you need to know that due to photosynthesis, oxygen is being produced and that would be then carried out by respiration by humans. But due to the small population of humans, less respiration was carried out and that's caused an increase in the oxygen levels. Okay, now glucose, which was produced, that's used by the plant for energy. Okay, glucose is a storage of food for the plants and it's there for growth. You need to know the word equation, which is this over here, word equation, and you also need to know the symbol equation, which is here. Just remember that everything has a 6 in front of it apart from glucose, and remember the formula for glucose itself, C6H12O6. We've got carbon dioxide, water producing glucose, and oxygen. Okay, so to summarize, the oxygen levels increased due to photosynthesis. Okay, and this is the equation you need to know for photosynthesis. Okay, so we've looked at the Earth's early atmosphere. We've looked at how the carbon dioxide levels decreased, and we've now looked at how the oxygen levels increased. We now need to look at greenhouse gases. Okay, and these are the greenhouse gases you need to know. Okay, now greenhouse gas is actually important for the Earth, and that's because they help maintain the Earth's temperature. If we didn't have any greenhouse gases, the Earth would be freezing, and we would be freezing and it would be cold, and you wouldn't want that experience. That's why we have greenhouse gases. Okay, so the greenhouse gases that we have are water vapor, carbon dioxide, and methane. These are the 3 greenhouse gases you need. And the greenhouse gases, their overall aim is that they act as an insulating layer in the Earth's atmosphere. So they prevent heat being lost by the Earth. Okay, so in other words, they keep the Earth warm. Okay, they keep the Earth warm, they prevent heat loss or outgoing heat. Okay, so to summarize from this slide, the greenhouse gases maintain the Earth's temperature. Examples include water vapor, carbon dioxide, and methane. And the overall aim of these greenhouse gases is to act as an insulating layer in the Earth's atmosphere. So they keep the Earth warm, in other words. They prevent heat loss or outgoing heat. Okay. Now, the final thing we need to look at for today's lesson is the greenhouse effect. Okay. So the greenhouse effect is here. I've condensed it into as little words as I can just to make it simpler. Okay. So there are three components involved within the greenhouse effect that you need to know. So we have the sun, we have the Earth's atmosphere, and then we have the surface. Okay. Now, the sun radiates wavelengths, so it gives us light. Okay, so the overall purpose of the sun is that the sun gives us light, and it also gives us heat. Okay, the Earth's atmosphere has greenhouse gases. Okay, and the surface is where we are. Now the sun gives out light and heat to the Earth's atmosphere. Okay, and this is in the form of short wavelength radiation. Okay, so this is short wavelength radiation. Okay, so the sun emits short wavelength radiation, and the only thing that you need to know here, short wavelength, is that the waves are narrower. So the waves are more like this. They're more shortwave. Okay, so we've got shortwave radiation there. So this you would classify as shortwave radiation, and this would be more longwave radiation. Yeah, because there's more of a gap between the peaks and the troughs. Okay, so this is shortwave, and this is longwave. Now the key point you need to know is that the sun to the Earth emits shortwave radiation. Examples include ultraviolet or visible light. Okay, so we've got some examples there, e.g. ultraviolet, and you need to know these examples: ultraviolet or visible light. Okay, so we've got two examples there. Now, when it reaches the Earth's atmosphere, most of it passes through. Okay, most of it passes through to the surface of the Earth, but some of it does get reflected. Okay, so most of it passes through to the Earth's surface, but some of it reflects back to the sun. So it reflects back to space or the sun. So most passes through, but some reflects into space. Okay, so we've got most of it passing through to the surface, however, some is reflected back into space. Okay, and at the surface, we can see that the light is absorbed. So the light is absorbed. And then the surface, after it absorbs the light, it emits another radiation. So as you could see over here, the wavelength radiation was short. The surface emits long wave radiation back to the Earth's atmosphere. So the light is absorbed and then the Earth emits long wave radiation back to the atmosphere. Okay, and this is long wave. Okay, so more longer wave radiation. Okay, and you also need to know an example. So an example is an example is infrared radiation. Okay, now when it emits this infrared radiation, the greenhouse gases which are in the atmosphere, they absorb this radiation, and that causes the temperature of the Earth to increase. Okay, so the greenhouse gases, what they essentially do is that they absorb the long wave radiation, and that causes an increase in the temperature. Okay, and that is basically the greenhouse effect. Now I'm going to go through it one more time just for the people that are struggling to understand this. Basically, the sun emits short wavelength radiation, and we see the sun giving us light and heat. And if you imagine the light and heat coming, those are basically the waves, and those are short wavelength radiations. So they give us short wavelength radiation. So just remember that, short wavelength radiation to the Earth's atmosphere. Examples include ultraviolet and visible light. Now, the Earth's atmosphere absorbs most of it and allows the light to pass through, but some of it is reflected back into space. Okay, but the majority of it passes through to the surface of the Earth. At the surface of the Earth, the light is absorbed, and then the surface emits long wave radiation back out to space, which is an example is infrared radiation. However, we have the greenhouse gases at the atmosphere, and they absorb the radiation. Instead of putting it back into space, they absorb the radiation and they conserve the energy. Okay, so the energy is conserved. Energy is conserved, and if the energy is conserved, that causes an increase in the temperature of the Earth, and that's what allows us to feel warm on a sunny day, and that is also what makes us feel cold on a cold day. And that's because on a cold day there's minimal sunlight entering the Earth's atmosphere. That means less energy is being conserved because less is entering the atmosphere, and that's essentially what makes us feel cold. Okay, on a hot day, when the sun enters, the surface radiates long wave radiation back to space. However, due to greenhouse gases in the atmosphere, the greenhouse gases absorb the radiation and conserves the energy in the Earth, and that causes an increase in the temperature. Okay. Now, if you've been watching the news over the past few years, the Earth's temperature is increasing, and that has caused many consequences. We're not going to have a look at that in today's lesson because of time, but it's caused a lot of consequences, and now they're working to reduce the amount of greenhouse gases that are in the atmosphere because of things like deforestation, burning fossil fuels. We're seeing an increase in the amount of greenhouse gases being ejected into the atmosphere. If there are more greenhouse gases into the atmosphere, that means more energy is being conserved, and that means more heat is being released by the Earth. So that's caused an increase in temperature. Okay, and an increase in temperature causes habitats to be destroyed. There are many consequences of this. So we need to try control this increase in temperature. Okay, and that's what many weather stations are trying to do these days. That's their aim. Okay, so we've looked at the greenhouse effect. If you're struggling with this, please let me know. You will be getting a recording to the session. So if you're struggling, you can watch the recording over again. But we have time now. If anyone is struggling with this specific greenhouse effect, you can let me know and I can go over it once again. Okay, so we've covered all the topics for today's lesson. We've got quick fire questions over here. So I've basically picked out all the questions that summarize today's sort of lesson, and I've put them on the screen now. You can either answer these questions now in the Q&A, and I can mark them for you, telling you how you've done, or I've got a link to a form which you can fill out, which has the same questions, but it's more interactive. So if you would rather fill out the form to the questions, I'm putting it in the Q&A. So I've put it in the Q&A now. You can click the link and you can answer the questions on the form. Okay. So I've put the link in the Q&A. If you would rather answer these questions in the Q&A, then feel free to do so. If you would rather answer it on the form, then you can click on the link and answer the questions. Okay, so it's just a summary of what we have done in today's lesson. If you don't feel like answering the questions, if there's any specific questions that you are struggling with, you can let me know and I'll go through them now. Or you can do the form in your spare time. It's completely up to you. Okay, so just let me know if there's any specific questions of those 6 that you want me to go through, or there's anything you don't understand. I'm here to answer it for you. Okay, so hopefully you've had a read of those questions, and if you're struggling, please let me know. I'm just gonna go through some exam questions for now. Okay, so I've made this exam question pack and we've sent it out to you guys through email, and you're given the mark scheme to these questions as well. After you finish the topic, it's really important and beneficial that you test your understanding with some of the past questions which have come up. Okay, so I've picked out these exam questions based on what we've done in today's lesson. So the 2 topics we have covered in today's lesson, these exam questions are based on those 2 only. And here I've just given you a feel of the different types of questions which can come up. I've also given you the mark scheme so you can test your own understanding of the questions. You can look at what the mark scheme was. Mark schemes are really picky, so you need to make sure that you're writing down what the mark scheme actually wants. Okay, so we've got a simple multiple choice question over here, and you just need to pick an option. Here we've got a graph, and it's a calculation question, so it's applying your math skills to this question, and it's 3 marks. Now this question, is the big one, and it's the one which tricks most people up. So describe the processes that have caused the main changes in the percentage of the carbon dioxide levels in the Earth's atmosphere over the last 4.6 billion years. So the key thing what this question is asking is the carbon dioxide levels. And we've looked at the carbon dioxide levels as well. So we've got the carbon dioxide levels that we need to pay a focus on. And we need to look at the main changes over the last 4.6 billion years. And it's 6 marks this question. So the carbon dioxide levels, the first reason is most of the carbon dioxide dissolved in the oceans. Okay, and we also know that the second reason is that plants use the carbon dioxide to photosynthesize. Okay, and the third reason is that the carbon becomes locked in organisms after they die. So you could also say that they become locked in organisms or locked in rocks from the seabed, because remember the carbon dioxide dissolved in the oceans as well. Okay, now just putting these 3 points would get you 3 marks. It would get you 1 there, 1 there, and 1 there. Now the other 3 marks, where they come from, is the actual explaining of the process. Okay, and I'm going to show you the mark scheme for this question now. So it's question 1.3. So here, this is what the mark scheme says. During the first billion years of the Earth's existence, carbon dioxide levels increased due to intense volcanic activity. So volcanic activity, it doesn't only increase the nitrogen levels, but it also increases the carbon dioxide levels. From 4.4 to 2.7 billion years ago, if you're wondering where it's got these figures from, it's actually from the graph, which is here. Whenever you're given a graph in an exam question, always use the graph, because that's a key essential part of the mark scheme. Okay, so if we over here, you can get level 1 to 3 marks, where the facts are just identified. That's what we've basically done here. We've just identified the facts, and that's going to give you a maximum of 3 marks. Okay. Level 2 is when you've got relevant facts, events, and processes are identified. And that's what we need to do. We need to use some of the figures from the graph to explain our point. Okay, so carbon dioxide dissolved in the oceans, rocks are formed, trapped in rocks. We could also say plants evolved, photosynthesized. You could also say fossil fuels formed, and we've basically stated those points. What we need to add to this answer is that evidence from this graph. We need evidence from this graph to explain our points, and if we use evidence from the graph, that will give you the 6 marks. Okay, now here again, simple multiple choice, another greenhouse gas. We've looked at specific ones. It says tick 1 box. Now the greenhouse gas that examiners are you looking for is methane. Methane is the greenhouse gas that they are looking for, because whenever it's talking about carbon dioxide, we also associate methane with that, because methane and carbon dioxide are the 2 main greenhouse gases which are resulting in global warming. Okay, Now, nitrogen is not a greenhouse gas. Nitrogen, there's a lot of it in the atmosphere, but it's not the ultimate cause for global warming. Oxygen is not, and argon is not. We're asked to give two effects of global climate change. Now, we've not covered that in today's lesson, but if you apply your knowledge, if we're increasing the Earth's global temperatures, what will that cause in the atmosphere? So basically, you're talking about habitats being destroyed, melting ice caps, glaciers. That's basically what you're talking about, the effects of global climate change. And again, we have another calculation question over here. It's testing your math skills. Give one way that carbon dioxide emissions can be reduced when a plastic bottle is manufactured. Now, this is more of Unit 10, but it's associated with this question as well. Carbon dioxide emissions can be reduced is making the design more sustainable. So don't worry if you don't know this question, because this is more of Unit 10, which we've not really covered in today's lesson. And then finally, we've got another extended answer. Now, in an exam, whether you're doing combined science or you're doing separates, this question normally comes up whenever you're asked about Unit 9, Chemistry of the Atmosphere. Just like we've had in this question, a 6-marker, main changes of carbon dioxide, we're also given a 6-marker on the percentages of nitrogen, oxygen, and carbon dioxide in the Earth's early atmosphere and the modern atmosphere. So basically, here, all we're talking about is basically this table over here. You need to learn your figures and you need to explain it, apply it to the question. Okay, if I show you the mark scheme for that last question, over here, nitrogen increased, oxygen increased, carbon dioxide decreased, and it's all about explaining why. Now, in this type of question, there's 3 levels, and level 1, you would get 2 marks for just stating that nitrogen increased, oxygen increased, and carbon dioxide decreased. You would get a maximum of 2 marks. Now, if you explain the points briefly, that would get you a maximum of 4 marks. And then if you fully explain your points and link them to the modern atmosphere, that would get you your full 6 marks. Okay, so we've just had an overview of the exam questions that I've put in the question pack. Now, instead of me going through the questions, I've looked at all the questions and we've covered most of them in today's lesson. I think it would be more beneficial for you guys to have a look at the questions and have a go at them and then test it by looking at the mark scheme after you've answered them to see what the mark scheme actually wants. So I've actually told you here what you need to include in your answers. Now it's your job to see if you can write them. Okay, I've put the mark scheme there and you've got the question packs, so you can just test your knowledge, and if you're struggling with anything, you can watch the recording to the lesson, which we will send out after a few days after it's been uploaded. Okay, so if we go back now, and also if you're struggling, you can just email me any questions you're struggling with and I'll get back to you with a response. Okay, so these are your summary questions for today's lesson, and I pasted the link to the form for these questions in the Q&A. Okay, now this session was only a trial session of what we would actually be providing in the GCSE Summer Crash Course 2023, and it's going to be starting next week from the 1st of July. Okay, so it's an intensive period of learning and it's held over 2 months, covering the full content of a variety of subjects. So the subjects we are providing include biology, chemistry, physics, and maths. Okay, You can attend all 4 subjects, or you can choose whichever ones you need support with. Okay, they're going to be running weekly, 3 hours per subject. So we have 1.5 hours on Saturday and 1.5 hours on Sunday. Okay, so 3 hours per week, 1.5 on Saturday, 1.5 on Sunday. We provide all this list over here. We provide the curriculum list with the specified learning objectives. We provide the PowerPoint presentation to each lesson, topic-based exam questions, practice papers, live lesson with the Q&A link, topic-based notes, recordings for each lesson, and we also provide your own personalized learning platform. Okay, and the purpose of this platform is so we can set you assignments, help you with any questions, learning resources, basically providing support, the support you need to excel with your learning. Okay, and we have biology, chemistry, physics, maths that we are providing. Okay, and we have the link here. This link will be emailed to you guys. It's not free. We're only charging a cheap amount compared to the amount of resources we are providing. We are offering it as cheap as we can at £5 per hour. So if you would want to join the lesson, you would need to book using this form. We will send you an email with the post-course material with the form in and next steps to how you book. But if you're interested, you can book using the form. So this was the chemistry form of the summary of what we've done, and this is the GCSE Summer Crash Course 2023 form. Okay, again, it might look like a lot, but it's ultimately just £5 an hour. Okay, and it's the lowest we could have brought it. So basically, there's 4 pages on this, and you need to fill out this form, and then we will send you the next instructions. Okay, and that brings our lesson to an end. If anyone has any questions, you can let me know now in the Q&A. If not, then you can leave the meeting. We will send out the post-course materials as soon as this has been uploaded, so you can watch the recording. If you have any questions, please let me know. If you have any questions about the lesson or about the GCSE Summer Crash Course, you can let me know now in the Q&A. Otherwise, you can leave the meeting, and I hope to see you soon. I'll stay on for a couple of more minutes if anyone has any more questions. If anyone did fill out the form for the quiz that I posted for the session, I've given back your feedback. Okay, it's 5 o'clock, so I'm going to leave the meeting now. Thank you everyone for attending today's session. If anyone has any more questions, you can let me know by email. You can email them over to me and I'll get back with a response as soon as possible. Thank you everyone for attending today's session, and I hope to see you soon.